if you remember, from our last session, we talked about the the perceptron. It was this mathematical model where we had these features, and with each feature was associated a weight. Let me actually pull that up. If you remember, we talked about this very fundamental component of a neural network. So it has, these inputs, and each input corresponds to a feature of the data set. So again, to use a real estate example, the features of a property, it's the number of bedrooms, the number of bathrooms, the size of the apartment. And these are the weights. Now, in machine learning terminology, we also call these parameters. So weights, parameters, these are the same thing. Parameters and weights refer to the same thing. So here, the purpose of the training data set is to let the model learn the parameters, to understand. It's all statistical calculation. But we want the model to calculate the weights. Now, if you have a regression problem, the way you find the weights, there's something called the computing formula. Again, it's nothing more than basic arithmetic. Maybe we can talk about that later on. But it has to do with the observations and the residuals. And the residual is the distance of the observation from the regression line. If you've watched the video that I referenced, you'd be familiar with these terms. Anyway, in the training stage, we want the model to learn the parameters. Sometimes training and validation is done in one go. So depending on the library that you're using and the machine learning model that you're using, you may need to have three divisions. So you will take your original data and divide it into three: training, validation, and test. Other times you can just have train and test. The purpose of validation is to check the metrics, to identify underfitting or overfitting. We've said that underfitting is when the model has not been able to calculate the weights properly. And you can easily detect this, because as soon as you look at the metrics, let's say we talk about MSE. If the MSE is large, it is diverging from zero. For the training data set, that's underfitting. So we don't go any further. We don't even proceed to test. So if that happens, then we'd have to adjust our data or adjust our machine learning model. And that is if we can even do something about the data, because sometimes the data is so sparse, so unusable, there's not much you can do about it. You know the saying, garbage in, garbage out. So we need to make sure there's no garbage. But another purpose of validation is for the model to adjust the parameters after it has learned. So after it learns the parameters, even if the metrics are good, let's say MSE is good, we want it to be better still. So in this validation stage with the validation data set, we look at the metrics, and then if necessary, we change the hyperparameters. Now, do not conflate parameters and hyperparameters. Unfortunately, there's one library, at least, Scalar, very popular library. They use these two words interchangeably, or at least when I look at the documentation, that is the case. That's a problem, because hyperparameters and parameters are different things, very different things. The parameters are the weights that the model must learn. The hyperparameters are like the arguments of the function. So we will have, let's say, a machine learning class like sequential. And the sequential class can take different arguments. We will see this in a minute. You, as the data scientist, must choose the hyperparameters. They're effectively arguments of a function. So you must change the architecture of the neural network, if in the case of deep learning, until you get a better combination. So as a machine learning, if you're doing machine learning, there are two things you need to fix. or two things you need to take into account: the quality of the data, and the type of machine learning model you've chosen, and the configuration. So actually, that's a better word for hyperparameters, is the configuration. Hyperparameters equals configuration of the model. Now, in order for you to find out if this model is usable and can be put into production after the best possible configuration, after the best possible data munging. Data munging is where you clean the data, you do feature engineering. So assuming you've picked the best possible model and you have produced the best possible data, if this model is going to be useful or not, and that is to use a test data set. So the test data set, after the test data set, we will check the metrics after the adjusted model, after the model has learned the new parameters. So if after the test data set, your metrics are still poor, then the model is not the right option. That is assuming your data is, your data is in the best possible condition. So if that's the case and your model is still poor, then you need to choose a different model. Either that, or again, you need to check the hyperparameters. So if you find overfitting here, then you must go back to what comes before the training stage. Okay. So in our case, we just need training and test. The training data set would allow the model to learn the parameters, and the test data set we will see if we have underfitting, overfitting, or if we are on the right track.